Hello everyone. For our third lesson in this week, I'm going to discuss the trigonometric ratios of the last special angle, 45-degree angle. And after you watch the video, you should be able to define the 6 trigonometric ratios of 45-degree angle, and you should be able to find the 6 trigonometric ratios of this angle. And for this discussion, let us consider another special right triangle. And this is the 45-45-90 degree triangle, or also known as the isosceles right triangle. As we all know, this type of special right triangle is half the square which is cut along the diagonal. Okay? Now suppose we have this special right triangle, we know that each of the acute angles is 45 degrees. Okay, so let us name this special right triangle as right triangle ABC. And when it comes to the properties of this right triangle, we only have two. Okay? Now, before we proceed to those properties, let us label those three sides. One is the longest, denoted by symbol letter C, and the other two sides are the legs, which are denoted by small letters A and B. Now, as I have said a while ago, this special right triangles has two properties or theorems, which I think we have already taken this up in the last topic in the third grading period. And what are these properties? So let us have the first one. The hypotenuse, okay, in this special right triangle, the hypotenuse is square root of 2 times as long as each leg. Mathematically speaking, that is C for the hypotenuse equals A times the square root of 2. Okay? So it means this length, which is denoted by small letter C, is also equivalent to A square root of 2. Now for our second property, in this right triangle, the legs are congruent or equal in length. Meaning these two sides that form a right angle are equal in length. Meaning, or mathematically speaking, that is A is equal to B. Okay? Meaning this length is also this length. And they are equal. Okay? Now, so B here can also be labeled as A, which means that these two sides are equal in length. Now, just like what we did in the other special angles such as 30 and 60 degrees, we're going to define the 6 trigonometric functions of 45 degrees. Now, since the two acute angles are the same in measure, we can only consider one acute angle here. Okay? So, say we consider acute angle A. And at this point, we're going to define the 6 trigonometric ratios of angle A, starting with sine of A, which is equal to opposite leg A over hypotenuse C. And next, for cosine of A, that is adjacent leg B over the hypotenuse C. And for tangent of A, that is opposite leg A over the adjacent leg B. And at this point, we just defined the three basic trigonometric ratios. Now we go to the next three, and these last three are called what? Reciprocal trigonometric ratios. So the first one is cotangent of A, that is equal to B over A Basically, it is the reciprocal of tangent of A. Next, we have secant of A, which is equal to C over B, which is actually the reciprocal of cosine of A. And finally, we have the cosecant of A, that is equal to C over A, and this one is the reciprocal of sine of A. Then, at this point, we replace A by its equivalent. We know that capital letter A denotes an angle, which is angle A. And we know that from this right triangle, angle A measures 45 degrees. Therefore, from sine of A, we have now sine of 45 degrees, which is now equal to A divided by the equivalent of C, which is in terms of A. So looking at the figure, that is also the same as A square root of 2. Therefore, we have A divided by C, which is now replaced by A square root of 2. And at this point, you will notice that this fraction has a common factor of A from the numerator and the denominator. So we will cancel that common factor from numerator and denominator, and what will remain from this fraction is what? 1 over the square root of 2. And since the value has a denominator with radical sign, we need to rationalize the denominator from this fraction. So we multiply this fraction by square root of 2 over 2, and then simplify this further. We have square root of 2 over 2, which is your sine 45 degrees. Okay? Next, how about cosine of A? That is also cosine of 45 degrees. That is B over C. Since B is equal to A, so we could replace B by A, then over C, which is the same as A square root of 2. And just like the first trigonometric ratio, we have a common factor of A from the numerator and denominator, so we can cancel this out. And what will remain here is what? 1 over the square root of 2, which is the same as the value of sine 45 degrees. Now, if we're going to rationalize the denominator from this fraction, the simplest form would be what? Square root of 2 over 2, which is the same as the value of sine of 45 degrees. Okay, so that is your cosine 45 degrees. Square root of 2 over 2 also. Next, tangent of A, that is also tangent of 45 degrees, which is equal to A over B, which can also be replaced by A since the legs are equal. So A divided by B, which is also A, and we know that is equal to 1. Therefore, tangent 45 degrees is equal to 1. Next, for the cotangent of A, so that is cotangent of 45, which is equal to the reciprocal of tangent of A, which is A over B. So here we have B over A. Okay, B over A. But since B is also equal to A, that will now become A over A, which is the same as the value of tangent of 45 degrees, which is 1. Okay? Next, for the secant of A, that is secant of 45 degrees, which is the reciprocal of cosine. So that is C over B. We know that C is A square root of 2 and B is also the same as A. So if we're going to cancel A from the numerator and denominator, the remaining value is square root of 2. Therefore, secant 45 degrees is equal to 2. And for the cosecant of A, or that is cosine of 45, C replaced by its equivalent, we know that is A square root of 2 over A. And the same as the previous one, we can cancel A from numerator and denominator. And what will remain from the value is what? Square root of 2, which is your cosecant 45 degrees. And at this point, I have just discussed the 6 trigonometric ratios or functions of 45 degrees. And this is the set of what we have just derived from the trigonometric ratios of 45 degrees. And please take note of the following values together with those uh, values from the previous topic that I have already discussed. The trigonometric ratios of 30 degrees and the trigonometric ratios of 60 degrees. Okay, this one. And that's all for now. See you next time.